Hey, welcome, folks. This time around, we are interested in tackling the 10 worked examples that we have there. So the first problem we are interested in, limitations of a file-based approach when we are storing data. Now, this is a scenario where, for instance, we can look at a school system that stores data in separate files for marks, fees, and attendance. This causes inconsistencies. So we can say a school database storing information for fees, for instance, attendance of students, uh, attendance, sometimes textbook information in separate files. What's the limitation? It leads to data inconsistencies. In other words, data can have potentially different meaning because it's stored in different locations. Then the second problem that we have there, we are interested in a relational solution to say, what do we do in case we want to get rid of a repetition of data storages? Here we can make use of tables. Let's see how we can bring in tables. A table can be defined as table student because it's going to store information of students within a school environment. Then when we have that table, what are we interested in storing? In other words, the fields that we need within a table, the student ID as well as name. And after that, we've defined our table. Then we also have another table which stores marks. But because we want a connection between these two tables, it means in the table marks, there must be a connection. We can bring again student ID because we don't want to repeat the names and all that in both tables. Then we can also look at the subject that the student takes as well as the score that one is achieving in that particular subject. Then next we are interested in a description of a simple entity relation diagram. So here we might look at entities such as, so when we say entities such as student and score, because each student has got a particular score that they attain, and then the relationship is student enrolls in a particular course or a particular subject. So enrolls in a particular course. But now we want to talk of cardinality of this relation to say, but many students can enroll for a particular course. So this type of cardinality is many to one. Is many to one. That's the type of cardinality we have there. Then can we try and test first normal form violation? When we talk of violation, in other words, we are saying there is a repetition in field of data stored. So here we can look at subject and student again. Subject, let's say subject and, well, it's student and subject. Well, let me just write it properly. Student and subject, student, as well as subject. But we are saying in one of the tables, there's going to be multiple data such that we have a scenario where a student can call that student, maybe student A is having two subjects, for instance, math and computer science being taken by one student. So this type of presentation is not atomic. Why are we saying so? Because we've got two values that are stored in a single field. So this violates first normal form. In other words, we have broken that rule. So we want to convert to first normal form. Now, our conversion is going to say, well, let's look at student. Then we have subject. So we are going to break these two, that student A takes a subject like maths from the example we have above. Student A again takes computer science. So we have managed to split these two. And actually it's now cleaner because there is no multiple field within the same field. Then next we are interested in a DBMS feature to say what can we look at to say this is a database management system. Well, this one allows concurrency control and prevents two users from overwriting data simultaneously. So it prevents two users or multiple users from writing data concurrently. Well, this is likely to lead to data inconsistencies. One person is updated at the same time, so we don't know which direction to take. Then next, we want to look at data definition language. So if we are defining data here, it's either we are creating, dropping, or deleting a table. So if we want an example of data definition, we can talk of creation of a table. So let's create table. And this table, we can give it a name like student. Student is something that we've been working with. So we can call that table student. And when we have our table, what do we need? We need the fields that we find within the table, like student ID. It's a field that we might need in that particular table to uniquely identify any value within the student. In other words, that becomes our primary key. So we'll bring its data type that it is int and it's a primary key. In other words, that's the unique identifier of any given record within our database. Then what can we have next? You might be interested in name of that particular student. So name is data type, can be a variable character, and we can define the length to say what's the permissible length of the variable name. So we can put, for instance, 50 characters will be allowed for that particular variable. Then we close our definition. So that's an example of data definition language there. And then, say for instance, we are interested in inserting data. So this time around is data manipulation. But one thing we saw is we defined student ID as the primary key. So now we want an example of how we can load data into that particular table. So we can say insert, that's the command that we use if we want to add data into our table. So we want to insert into the table name is what we are bringing now, which is student. And which fields do we want? We want student ID as well as the name. So these are the values that we want inserted. So we can say values, then because it's integer and for text, we can surround it with quotes that this is textual data. Then we put colon to terminate our instruction. Then next, we are interested in querying. So if we are querying, in other words, we are retrieving data from our table. So this time around, we are going to use command select. And when we select, what exactly do we want to select from our table? We want to select name. And it's going to give us a list of all the names from the table student. So we can say, let's get all the names from student. Can close our query with a colon there to say we have queried our table. Then next we want to make an update on data. So if we want to update, we're going to update the table. So update, what's our table name is student. And what exactly do we want to change? If we want to change this time around, we want to set, we are targeting a certain value. So we want to set a certain name Tariro. That's what we want to change to say this name, Tariro M. That's what we want to set. But where do we want to set it? We are targeting the primary key to say this is the record that we want to uniquely update. So the student ID equal to 101. So we are saying when we pick this student ID, can we go to the name, we update it to Tyro M. I think basically that's what we have on the first 10 examples of problems that we had. So next again, we're going to run through 10 similar problems to check if there's variation in terms of the questioning style or the information required by the problems. Thank you. Bye.